Okay? And then now let me show you how I'm guesstimating the size of the minor axis. The minor axis is about like that. If I bisect them, it's right there. Again, it's in front of the center. Just a little bit closer to the viewer. Now let's talk about how I'm doing this. Everyone watch this for a second. Okay, let's imagine that we're seeing this in a side view, okay? And we've got something like that. Now, I've got the same kind of thing going on over here, right? Now I know it is certain that these points fall on my ellipse. But people tend to draw them like this. You know, and it doesn't look right. This is why the axis is so important. So these points are on the circle. Now watch this. The minor axis is one of the two extremes. Okay? So this is going to be a really determining factor for the ellipse. But watch this. Imagine if I draw this line. Does the circle at any point come inside that line? No. All right, so look. So that means the minor axis has to be somewhere between here and here. Does that make sense? There's just, okay, well, let's put it here. And if I do the same thing on the other side, okay, it has to be between here and here. So do you see what I mean? It's like someone telling you, guess a number between 1 and 100, but I'll give you a hint, it's between 57 and 59. 58? Yeah, you know, so that's kind of what we're doing here, is and now if you can find them, you find the minor okay, you cut it in half, you've got the major. You draw it perpendicular, and hey look, same thing happens. Well, the major is between here and here. Okay, how about this? And then if I double it, if I go like this, see now here I've got a little more of a range. So choose this one and double it. Hey, yeah, look, it falls outside that line. It's probably there. And then if I start to rough this out, hey, look, I hit all the points. Okay, now the other thing that you can do, actually I drew that a little too dark. Let me erase that. I realized I wanted to use this for something else. Where'd my eraser go? So let me just gently erase all this. Oh, you know what? I'll just do it on another sheet. Oh, now an interesting thing happens. So your guys' homework is going to partially involve drawing a bunch of ellipses. And actually, let me just go ahead and explain it. You know your 50 cubes?
Oh.
50 ellipses?
You draw ellipses on
Oh, well, ellipses on cubes.
What I would like you guys to do is take the practice side, take the corrected side, and I would like you to draw ellipses on the visible sides. Okay? So between 100 and 150 ellipses. All right, and now focus on two things. Focus on getting the correct axis alignment and symmetry. Yeah.
How do you know when you exactly bisect the marker?
When you eyeball it.
So it's just kind of.
Yeah.
Okay.
I mean, if we're doing it mechanically, then yes, there's an issue. You know, like you can do it mechanically, but for our purposes, I want you to eyeball it. Now, another thing I want you to notice. So, if this is an ellipse, right? My minor axis is going to look like this. Now, you'll also notice something else. If I bisect the back side, it's the same thing. And if I do something like this, okay, and then if I do something like this, you can now draw toilet tissue. Okay, so.
My life is complete.
Oh, just wait till next week. But now you can also do other fun things when you understand how ellipses work. Like you can do things like this. If you draw a sphere, there's the circle. Now if you take a couple of ellipses and use them as guidelines, you can do things like this.
Pac-Man.
So, do you guys see how cool these are? How happy you can become? Because now, when you are going to draw something like Mickey Mouse or Homer Simpson or any animated character that involves a sphere, you now know how they work. And also, another thing, you guys are killing me in Sean's class because you guys do this stuff. You know, or let me do a better version, which isn't actually better. You're drawing nonsensical ellipses on your cylinders. They're not nonsensical. Right now, if you guys are drawing me, not a single one of you can see the top plane of the ellipse on my arm. You'd be looking up at it. And for my elbows, most of you would be seeing a line, because it's at your eye level. Ellipses establish eye level. Okay, because of degrees. So if you're looking 10 degrees up, what proportion ellipse do you have? 1/5. You see what I mean? A 1/5 ellipse. You see how powerful this stuff is? Because now you're looking down on you're looking down at someone's feet. If you draw their feet, say like this, and you're looking down at, say, a 30-degree angle, you can put their feet touching anywhere on that circle and it will look correct. This stuff is huge. Now, this is a highlight from the next lecture, but you guys, the way I want you to think of it is cubes give you rotation. They tell you what, how something is oriented horizontally, side to side. Cubes give you that. Ellipses give you how something is placed vertically. So if you have both, You have everything. Yeah, I want to draw. Just wait till you guys see the next lecture. Oh my God! All right, now hang on. Let me make sure I'm not forgetting anything here. Oh, let me show you one. This is important. And then if we have any time left, I'll talk. Yeah, this is perfect timing. Okay. Because I'll do this in about 5 minutes, then we'll have 10 minutes to discuss homework. All right. So, why is it that the minor and major axis, why is the major axis never through the center of the square? You know, when you have the center of the square, it's the center of the circle. Why isn't it the center of the ellipse? Do you see how that's kind of bizarre? Let me show you exactly why that happens. When you have a square like this, and you bisect it, there's the center. Do you see that it's closer to the back line than it is to the front line? Okay, now watch. If we have a circle, let me do this. Now let's say we have a viewer looking, this is a circle and the viewer is looking at it, this is a top view. The viewer is looking at it from here. Okay? Now, this is the widest point of the circle. But look. Visually, it is not the widest point of the ellipse. The widest point of the ellipse is there. So, what that means is, if you're looking at an ellipse over here, this half, or I'm sorry, this half of the ellipse is equal to this. That half of the ellipse is equal to all of that for exactly this reason. Does that make sense? Okay, so never place the major axis at the center. Now, it'll be closer and closer and closer to the center the more full the ellipse becomes. The more shallow the ellipse becomes, the more it'll shift, but it still won't, it will look close because you've got a shallow ellipse. But it's never at the center. It's always a little bit closer to the viewer on that side, whatever side it is. All right, now, so everything makes sense so far? All right, you guys, so let me give you the homework assignments in order. All right. The first thing is I want you to take your 150, or I want you to take your 50 cubes, and I want you to draw ellipses on the corrected side, on only the visible side. So only the 2 to 3 sides of the cube that are visible to the viewer on the corrected side. Now, I want you to be consistent because it makes it a lot easier to tell if you're doing it right or not. You should be using like a red pencil for the corrected side. I'd like you to use like an orange or a red pencil for the minor axis. For the minor axis. All right? Use a green pencil for the major axis. And draw the ellipses in any color you want.
Green for major.
Green for major, red or orange for minor.